So here we're first given the definition of a palindrome. It's any integer that reads the same backward and forward. So for example, 232 would be an example. Now this particular question is asking about a 6-digit palindrome. And the question is, it must be divisible by which of the following? So you want to pick up a different example, something like, say, 145,541. Reads the same in both directions. I'm deliberately choosing something different from that because I know most students are going to do that, and you'll see multiple of these numbers will work. Now, if you look at this, I can add up the digits. This is 10, just this part, and that's another 10. So sum of the digits is 20, and this number will not be divisible by 3 because 20 is not divisible by 3. Same thing with 9. The rule is the same. The sum of the digits is divisible by 9, then the number is also. And for the remaining 3, we'll just use the calculator. If you divide this by 7, it's not divisible by 7. If you do it by 11, you'll find that the result is it is divisible. So we know that this is one possible answer. And then for 13, if we divide it by 13, you'll find it's not. So we have our answer immediately. But there is a general concept behind this problem that relates to place value, and you might see it in a different problem, and I want to review that. It's not terribly useful for this particular problem, but it will be useful. So now in terms of place value, this just means A, this would be 10B, and then I have 100C, I'm going from the back, and then plus 1000C, then 10,000 B, and then I have 5 zeros. Actually, yeah, no, this is 6. So I have 100,000 A. So this is our number. Now if I were to add these up, meaning combine the A terms, so this would be A, and then I would have 10,000 10B, these two terms, and then plus 1100 C. So I want to see what number I can factor here. So I notice immediately I have 11, so I have to check if these are divisible by 11. If I factor in 11, here I'm going to get 100C. This number 10,010, 11 times 9 is 99, 1, 11, and so it's 910. So this is divisible by 11, and then this final number, you can even just use the calculator when you're factoring, so you don't have to do that. So if I divide this by 11, it is indeed 9091. And the key thing of doing this step is that we'll notice that any 6-digit palindrome where the digits it reads the same forward and backward will always be a multiple of 11. It's 11 times something. That means it must always be divisible by 11. So that's the concept behind this problem, why that is the case. This sort of an approach is useful for other GRE problems, and I wanted to make sure that you saw this. For this particular problem, it's not necessary, meaning you could just create some examples and test it. So to summarize, the answer is D.